Alright, let's take a look at converting recurring decimals into fraction form, part of GCSE Maths. So in the previous video where we had fraction on negative indices, in question 18 of it, we had converting a recurring decimal to fraction form. And it didn't cover it in that video because it's going to be a long process, and I thought I'd make a separate video on it. So here it is. Converting recurring decimals to fractions. First of all, let's look at converting just normal decimals to fractions. Well, that's pretty easy, right? So it's going to be like 0.7. Well, that's 7 out of 10, right? Because remember, decimal form is going to be out of 1. 1 is equal to 1 out of 1, or 10 out of 10, or 100 out of 100. You know, that's how the decimal form works. If the decimal form is bigger than 1, so 1.5, then the numerator is going to get bigger too. So if it's 1.5, it's going to be 1 out of 1 plus a half, which is going to be a half plus 1 out of 1. Well, we can write that as 2 over 2, right? So it's 2 over 2 plus a half, which is 3 over 2. Anyways, that's what we're here to do. Let's look at recurring decimals to fraction form. So let's say we have the recurring decimal 0.473 recurring. Remember, we put a dot in front of the first and last digit that recur. So this, you could write this as 0.473473. It's going to keep going on like so. So how do we convert this into fraction form? Well, it's definitely not going to be 473 out of 100, right? Out of 1,000, sorry. It's not going to be this, right? Because if it's out of 1,000, it's just going to be 0.473, the non-recurring version. So it's definitely not going to be this. We have to find a way. But how do you express a recurring thing as a decimal? It's a bit strange, right? Well, there's a bit of a process we can do. It feels like you're cheating the system. You're like kind of like doing something that's not part of maths, and you're just cheating the system. But let's look at how it works. So we're gonna do something like algebra here. So R is gonna be equal to 0.473 recurring, right? This is the recurring number. 0.473 recurring is R. Now what we're gonna try and do is get rid of all these recurring digits to the left side of R. So R is gonna be these recurring digits. So how do we do that? Well, we can multiply this by 10 on both sides, right? If we multiply by 10 on both sides, this is going to give us 10R is equal to 4.73 for recurring, right? Let's try it again. Multiply by 10 again. I'll just put brackets around these so we don't get confused. It's going to be 100R is equal to 47, because we're moving one more decimal point, right? 47.347. Now, don't get confused by these digits, right? We're moving them one by one, so the next recurring digit's gonna come, because this is this is essentially 473473, right? And continuous. So when we remove 1 here, we're gonna have 734 coming next, and when we have 7 moving next, 47, right? We're gonna have 347. So we're pretty much back, and then we're gonna multiply by 10 again, and that's gonna give us 1000R is gonna be equal to 473.473, because we removed these 3 digits now, and now we have just these 3 left, and these are all recurring. So 473 recurring. So now when we multiply by 10 times 10 times 10, which is 10 times 10 is 100, times 10 is 1,000. So when we multiply by 1,000, or by 1,000, we got 473.473 recurring. So now you notice that we have 3 of the digits. So 473 is the digits that keep on recurring, right? So we have all the recurring digits on the positive side. It's not a decimal anymore. It's over 1. It's larger than 1. Now this is when we start to use a bit of maths. It's kind of like cheating the system. So R was 0.473 recurring, right? So this 473 is going to keep going forever. So we can minus R on both sides. Now R was 0.473 recurring, right? So that's going to get rid of all these recurring digits, because this R goes forever. So when we minus R, this R is going to get minused, and all the recurring digits are going to get minused by R. It feels like you're cheating, right? So when you minus 1,000 by R, it's going to give us 999R, right? And that's going to be equal to, well, all the 0.473 recurrings are gone, so we just have 473. And all we have to do is divide by 999 on both sides to get rid of the 999R, so that we only have R equals, well, you're dividing by 999 on both sides, so it's going to be 473 out of 999. And that's pretty much all you have to know about recurring decimals. Okay, I thought I'd do one more example, so let's take a look at the question we had last time, 0.037. And I told you guys last time that the answer was 1 over 27. So using this method, let's see if we can actually make it happen. So the number is 0.037 recurring. So just to help us visualize this is going to be equal to 0.037, 037, 037, and so on and so forth. Okay, so let's write it in the form r is equal to 0.037 recurring. We're going to multiply by 10 on both sides. It's going to give us 10r is equal to, what is it? This 0 is going to move over, right? So that's still going to be 0. I'll write 2 zeros just so that we can visualize this better. 0.370 recurring, right? So this 0 moved over, so now we have 370 here. Okay, let's multiply by 10 one more time. It's going to give us 100r is equal to 003.703, right? Because now we have the 0 and 3 moving over, so now we have these 703 digits remaining. Let's multiply by 10 one more time. That's going to give us 1000r is equal to 0037, because all these digits moved over now. All the recurring digits have moved over now. So now we have all fresh start 037 recurring again. So all the recurring digits have moved over. That means we can use our little glitch to minus r on both sides. Because minus r will be 0.37 recurring, right? So that's going to get rid of all the recurring digits here. So that's going to give us 999r is equal to 0037, and all these recurring digits are going to be gone. Now we can also write this as just 37 over 999, right? Because these digits, 00s, mean nothing. So we multiplied it by 10, by 100, by 1,000. So it's going to be 999. And we're dividing by 999 on both sides of the equation, right? So divided by 999, divided by 999. That's going to give us r is equal to 999, so over 37. And 999 over 37 can be simplified to become 1 over 27. Thanks for watching this one. And in the next video, I'll look at terminating recurring decimals. So it's not really terminating recurring, but what I mean by terminating recurring is, so you might get recurring decimals like 0.23, but only this 3 is recurring. So 0.2333, 3 recurring, so on, but not the 2. There's a bit of a different process. In the next video, I'll cover that. Anyways, thanks for watching this one, and I'll see you guys in the next one.